Hello, my name is Jared Skeens and welcome to Quick Fix. Today we want to look at IGCSE May-June series 2019, paper 23. It's an hour and 30-minute test. Again, we have it worked out and the goal is for you to learn how to set up the problems and to think your way through it so that you can be successful in these question types in future test sets. So let's get started here. First, we have write this decimal correct to two decimal places. So two decimal places would be the 8 and the 9. The number after it is the 7. So this 89 needs to round up to 90. And so it should be 1.90. Don't forget to put the 0 because it's two decimal places. Number 2, we want to factor this expression. So factoring, you look for what's common to all the terms. There's an x common, so we take out an x. Remember, with the coefficients, you're dividing out. With variables, you're subtracting the exponent. So 2 minus 1 gives you 1 exponent left, and the 2 is still there because there is no coefficient to factor out. And then when we take an x out of the x, or we divide it out, we get minus 1 here. So in other words, you're subtracting the exponent. 1 minus 1 is 0. Anything to the 0 power is 1. So you're taking out this x and you're left with a 2x minus 1 inside the parenthesis. Number 3, Julio's, if that's, or Julio, however you pronounce that, reaction times are measured in 2 games. In the first game, his reaction time is 1/3 of a second. In the second game, his reaction time is 1/8 of a second. Find the difference between the two reaction times. So 1/3 minus 1/8, you want to get a common denominator. Multiply the fraction on the left top and bottom by 8, giving you 8/24. Multiply the top and bottom on the right by 3, giving you 3/24. So 8 minus 3 is 5/24 is the difference between the reaction times. Number 4, the table shows the different methods of travel for 20 people going to work. You see a car, there's 10 people use car, 5 people walk, 3 people ride a bike, and 2 people take the bus. Which type of average, mean, median, or mode can be used for this information? So when it says which type of average, it's basically saying which type of statistical analysis can be used for this information. It gives you 3 choices here. Mean would be the average. Would that be the best for this? The median or the mode? So in this case, the mode, the one that occurs the most often, would be better to use for this. So it says again, different methods of travel for 20 people going to work. Which type can be used for this information? And the mode would probably be the better representation of the data than the mean or the median. Number 5, find the coordinates of the point where the line y equals 3x minus 8 crosses the y-axis. The key here is when you cross an axis. When you cross the y-axis, your x value is 0 because the y-axis is on the x equals 0. And if you were crossing the x-axis, then your y would be 0. So since here it's crossing the y-axis, your x value is 0. Plug your 0 in, y equals -8. So the coordinate of the point would be 0 for the x and -8 for the y. Write down the gradient of the line y equals 3x minus 8. Hopefully you recognize this as y equals mx minus or plus c, where m is the slope or the gradient. So the gradient is 3. Number 6, calculate -12 divided by -2. And so negative 12 divided by negative 2 is positive 6. If you were entering this into your calculator, you would want to put the negative 12 and the negative 2 in parentheses so that your calculator doesn't get confused on order of operations. Letter B, you've got the cube root of 2 cubed plus 2. Again, make sure that all of that is inside the root, and you should get 2.154 to 3 significant figures would be 2.15. Number 7, here's a list of numbers. From this list, write down a prime number. So prime number is only a number where it and itself can divide into it. And so that would be 31, and also the square root of 121, which is 11. 11 is prime, and 31 are both prime numbers. And then an irrational number. An irrational number is a radical that does not come out evenly. The root 121 came out evenly as just 11. Root 13 does not. That's your irrational number. Moving on, number 8, scatter diagram shows the number of people and the number of phones in each of 8 buildings. So on the bottom, you have number of people. On the y-axis, the number of phones. So one of the buildings contains 42 people. So we go here to 42, number of people, follow it up, and here we see where it's marked, the little X here. Follow that across. So there's 32 phones in that building. What type of correlation is shown in the scatter diagram? When you look at a scatter diagram, which is looking at all these little random X's here, what you're looking for is, do the points follow a slope? So if you look at this, these points are generally going in an uphill direction. So that would be a positive slope or a positive correlation. If they were generally going down, that would be negative correlation. And if they were like somewhat circular, no particular direction, then that would be neither. So it will either be positive, negative, or neither. This one is obviously going in an upward direction or like a positive slope. So you'd call it a positive correlation. Number 9, without using a calculator, work out 12/35 times 7/9. So here you can put them next to each other. You can factor your 12 and get a 3 times 4. Factor your 9, get 3 times 3. Factor the 35, get 5 times 7. So the 7s cancel, one on top, one on the bottom, because multiplication and division cancel out. They're opposites. And we have a 3 on the bottom and a 3 on top. So that only leaves us with the 4 in the numerator and 5 times 3, which is 15 in the denominator. So we get 4/15. Number 10, rearrange this equation to make W the subject. So we need to first of all divide by 2 because it's outside the parenthesis. So W plus H equals P over 2. Then subtract the H, and so you get P over 2 minus H with W as the subject. Number 11, here is an expression on one side, which is 4 terms. And what they're doing is they're factoring by grouping, and they give you one of the factors. So let's factor by grouping. Usually, not necessarily all the time, but usually you can just split it right into 2 terms on the left, 2 terms on the right. You look for what's common to both. On the left, we see there's a 9 for the coefficients and m squared for the variable exponent. Take that out. When you divide that out, you get 2m plus 1. And then on the right side, there's a 7 common to both. So we factor out the 7, and we also get a 2m plus 1. If what you have in the parenthesis is the same for both, then you know that you're heading in the right direction. If those are not the same, then you might want to go back and rearrange these 4 in a different way. But usually you can just split it in half. So notice we already have, now the 2m plus 1 is common. So if we take the 2m plus 1 out, that leaves us the 9m squared plus 7. They've already provided that. So the 2m plus 1 is the missing factor here. Moving on to number 12, we have a sector of a circle with radius of 6.2 and the angle is 217 degrees. They want us to find the area. Again, remember for IGCSE, they usually use the degree formulas. When you move up into AS level, they kind of switch over to the radian formulas. You do have to pay attention. This is not like trigonometry where you just simply change the mode on your calculator. You for sector area and arc length, you actually have two different formula sets, one for degrees, one for radians. So make sure you're using the degree formula for area. So in this case, you do pi r squared, where 6.2 is the radius. That's a complete circle. And since this is a sector, it means you have a fraction of the area of the circle. And you have 217 degrees out of 360 degrees. I didn't write the little degree symbol there. But here's your fraction of the circle. You multiply all that out and you get 72.79 to three significant figures is 72.8 centimeters squared. Moving on to number 7, here we have this pyramid. Write down the number of planes of symmetry. In other words, if you were to cut it in half, are both halves identical? So you got to think through it. You can cut it through right down the face, north to south. That's this way. And both halves will be the same. You can also cut it down the face east to west. Okay, so that will also give you uh, equal halves. And you can also cut it down the diagonal. So from southwest to northeast, down right down this edge here, and both sides will be the same. Or you could also cut it down this edge here and this one over on this side. So from southeast to northwest, if you can think in terms of directions. And so there are 4 planes of symmetry for that pyramid. Using a ruler and a compass only, construct a drawing of one of the triangular faces. Now, I think constructions have been eliminated from the new 2020 syllabus cycle. I haven't seen constructions yet in the year 2020, but we'll cover it anyway. So what we want to do is one of these faces, notice a base of 4 centimeters with the diagonals or the isosceles part of the triangle here being 6 for each side. So we'll start by taking your ruler and measuring out just 4 centimeters. So put a dot on each end. Then we're going to take your compass and measure out a 6 centimeter, spread your compass out to 6 centimeters on your ruler. Put the pointy part on the corner here and make a little arc because you don't know where this dot's going to be. So just make an arc here. Everywhere along this arc is 6 centimeters away from this corner. Then go to the other corner, put the little pokey part of your compass on this dot and run your arc this way. Where your 2 arcs intersect is your vertex, and then draw your straight line with your ruler to this vertex with these other 2 vertices here. And there is your isosceles triangle that matches the face of the pyramid. Moving on, here we have an equation where x is given. Notice this is a quadratic, meaning there are 2 solutions for x. They give us 1, x equals 7. So the first thing they want you to do is find a. So plug 7 into the x squared, you get 49a plus this a right here equals 150. That gives you a total of 50a equals 150. Therefore, a equals 3. So now that we have the value of 3, we can put the 3 back in here. Sorry, I didn't write the first step. It should be 3x squared plus 3 equals 150. I just mentally subtracted the 3 to the other side, giving you 147. divide by 3 gives you 49. Square root both sides gives you plus or minus 7. Don't forget to put plus or minus when you square root both sides of an equation. There are two answers to a square root. They already provided the 7, so the other solution is negative 7. 15 here, A is 0.712, B is 0.2 negative 1. Find the length of AB, or in other words, the distance between the two. So we're going to use our distance formula, which is the square root of, I did x2 minus x1 squared plus y2 minus y1 squared. Doesn't really matter which direction you go as long as you go the same for both values. So I did 7 minus 2 squared and 12 minus a negative 1 squared. So 7 minus 2 is 5, squared is 25. 12 minus a negative 1 is 13, squared is 169. And I don't know why I didn't put the little plus here in the middle, carry that through. So I didn't show my plus sign carried through. So please put that on your work. Again, I'm not sure why I missed that, but 25 plus 169 is 194. And the square root of that is 13.9. Okay, at least to 3 decimal or to 3 significant figures. I don't remember if that continues on or if it's exact, but 13.9 is your answer. Number 16, this is about upper and lower bound. So the area is 10, the height is 4, and we want to find the upper bound for letter B. So this one's a little tricky. Remember, again, there are usually two layers to these type of questions. The first one are the measured values themselves. So I took my 10 and I did an upper and lower bound. So it's between 9.5 and 10.5. Also did the upper and lower bound for 4, 3.5 to 4.5. Again, if this is your first time watching a video on this particular question type, the lower bound is included. The upper bound technically is not included, but we still write it with the 0.5. And now the second layer is the formula. Now we need, because it's asking for B, we need to rearrange the area formula and make B the subject. So multiply 2 to the other side and divide by the H. So B equals 2A over H. We want to find the upper bound of this division problem. So that means we want the numerator, in order to be, for B to be maximum, we want the numerator to be maximum. So we're going to use the 10.5 for the A, but we want the denominator to be minimum. You want to divide this by the smallest possible value so that B can be as large as possible. So you kind of have to think through those a little bit. So this is the second layer. So 2 times 10.5 divided by 3.5 comes out to 6. On 17, simplify this fraction. So what we want to do is factor the numerator and the denominator. The top is monomial factoring. You look for what's common to both. There's an x squared, and then you have an x plus 5 left over. The bottom is a difference of squares. So you have x plus 5 times x minus 5. Notice the x plus 5's cancel, leaving us with the reduced or simplified fraction of x squared over x minus 5. Number 18, here's one of our proportionality problems, and it's inverse. So that means it's going to be a division. Don't forget, on these proportionality questions, you have to provide the K. The K is the proportionality constant. You don't see it when you read it. You need to know from proportional that you have to supply the K. If it's directly proportional, it would be K times what you see over here. Because it says inversely, it's K divided by what you see over here. Again, read carefully. This is the square of x plus 1. So some students get confused between square and square root. So this is the exponent. Square root's the radical. The square of x plus 1, so you have x plus 1 squared. So y equals k over x plus 1 squared. So the first set of numbers you're going to plug in here. You're going to plug in and you're going to solve for the k. We need to know what that proportionality constant is. It's different for every problem. So we plug in x is 1, 1 plus 1 is 2, squared is 4. We put in the 0.875 for the y, multiply 4 to the other side, and our proportionality constant is 3.5. Now we could plug that back in for the k, and now we work with the second set of numbers. They give us the 4 for the x. We need to find the y. So you plug 4 in here, plus 1 is 5, squared is 25. 3.5 divided by 25 is 0.14. So y equals 0.14. If you've noticed, when I write decimals, I don't write the 0 in the front. I don't know, to me it seems like a waste of time, but 0.14 if you're used to putting the zeros in front of the decimal. The decimal tells us where we're located on the line, so 0.14 is what I put. Here we go to the circular or geometric properties of circles, and they give you this diagram here, and it says that JL is the diameter that's important, and they tell you there's a 104 right here, and they also tell you that MJL is 22. Now, when you have these confusing diagrams, it's what are you looking for? Not what am I looking at, because that's kind of confusing. It is what am I looking for? Our goal is to find this value of D. But so let's see what we're given. We're given this 104, and it is a vertical angle to this one over here. These are vertical angles. That means this is a 104. Now that's good because we have this 22 here. Now, another thing that we're given is that this is the diagonal or the diameter. And when you have an inscribed angle that opens to the diameter, then that means it's perpendicular. Okay, when you have an inscribed angle, meaning the angle touches the circle, and it opens to the diameter, then that is a 90-degree angle. So we have 104 from this being vertical. We have the 22, which means that when you subtract that from 180, you get 54 from here. You subtract 54 from this 90, and that gives you 36. So 36 opens up to the J and K, and if you notice, our D here also opens up to the J and K. So when you have inscribed angles that open up to the same arc, then that means these are equal, so your D is equal to 36. Now, notice I wrote a few other numbers down here, and that's because when I'm looking at a diagram, before I figure out the actual value of D, I'm just writing down everything that I see. So I noticed that this 22, when you multiply an inscribed angle by 2, that's the arc, so there's 44. Here's the 54 here that opens up to the arc, so multiply that by 2, that's your 108. And this 36 multiplied by 2 gives you the 72, and the arc divided by 2 again gives you the 36 for D. So I just start writing down things around the circle until I figure out how to get the D. You didn't need all of it, but sometimes you don't realize what you need until you make that connection. Okay. So moving on to number 20, we have a Venn diagram. There's 40 children are asked if they have a computer or phone or both. So there are actually 15 have a computer. There are 31 that have a phone. 8 of them have both a computer and a phone. There are 7 that only have the computer, 23 that only have the phone, and there are 2 that don't have either one. So it says a child is chosen at random from the children who have a computer. Write down that the probability that this child also has a phone. So that would be this section right here, has both the computer and the phone. So that's 8 out of all the ones that have a computer, which is 15. So you have 8/15. Now they want you to complete the Venn diagram where basically they do the opposite. So instead of have a computer and have a phone, now you don't have a computer and don't have a phone. So if you look at don't have a computer or a phone, well, that would be this 2. These two don't have a computer or phone, so don't have either one. That's the 2. If you don't have a phone, that's 31. Or sorry, that's have a phone. If you don't have a phone, that's 9. So that would, here's the 2 that don't have either. There's 9 that don't have a phone, so that leaves you 7 for here. If you don't have a computer, would be 25. So that's 2 and the 23. And then if you're not in the don't have, that means you at least have both of them, then that's the 8. So you have 8 that kind of not. So in other words, they do have both the computer and the phone. So these numbers are just kind of like the opposites of these up here. You got to kind of think it through as to where they go. You get 2 points for that. Then they say in this Venn diagram, that is, oh, this one down here, they provide you a different diagram. Shade the region that is the union, that is combining all of A with not B. So all of A is this, with not B is all of this, and then that intersect with C. So all of A, not B, intersect with C. So this was all of A intersect with C, and this part here is the not B intersect with C. So these 3 sections are what you shade. This one here is not in A, and it is in B, so that one is not included. Okay, so this means the union of A not B, that intersected with C. Number 21 are matrices. Again, the 2020 syllabus cycle does not include matrices, so technically you don't have to do this because we're now, actually this video I'm making it at the beginning of 2021, but the 2020 syllabus cycle does not include matrices, but we'll go through it anyway because matrices are important for further maths and in case you run into it. They're not that difficult. This is just a scalar number 5 multiplied through matrix A. Here's 3, 4, 5, 0. Multiply everything by 5. You get 15, 20, 25, and 0. That was pretty easy. Here, A plus B is again easy. You just write your matrices and add the corresponding elements. 3 plus 1 is 4. 4 plus 4 is 8. 5 plus negative 3 is 2. 0 plus 2 is also 2. So you get 4, 8, 2, 2. Here's matrix multiplication. A times B. The order does matter. We need to put A first. 3, 4, 5, 0 times the B, 1, 4, negative 3, 2. When you multiply, you do row times column. So the 3 times 1 is 3, plus the 4 times negative 3, which is negative 12. 3 plus negative 12 is negative 9. Notice it's first row times first column. So first row and first column puts it right here, the negative 9. First row times second column, 3 times 4 is 12, plus 4 times 2 is 8, 12 and 8 is 20. Then we go to the bottom row times first column, 5 times 1 is 5, and 0 times a negative 3 is 0, so 5 plus 0 is 5. And then we do the bottom row times the second column, 5 times 4 is 20, and 0 times 2 is 0, and you add those together and get 20. So this is your matrix from that multiplication. Number 22 is a diagram for vectors. Excuse me. So we see that N is on BD such that BN is 4 to 1 for the BN to ND is 4 to 1 ratio. We have AB as vector S and AD as vector T. Find in terms of S and T B to D. So B to D is end minus start. So it would be AD minus AB. So you might want to start writing down an equation with capital letters first. BD, notice these vectors here are tail to tail. That means you need to subtract. So you would do end, because we're going from B to D, we end at D. So AD minus AB, and when you convert that to the vector letters, you get T minus S. Then from C to N, we need to draw that arrow in. It's going from C to N. So you can go from C to B plus B to N. So I did write that in capital letters first. C to B is the opposite direction of A to D. So that's negative T. Remember, when you go in the opposite direction, it negates your vector. So negative T. And then we have only this part of BD. 4 out of a total of 5. So we have 4/5 of this T minus S. So that's 4/5 T minus 4/5 S. So a negative T plus 4/5 T is a negative 1/5 T and the minus 4/5 S. So just simplify that algebraic there. Moving on, we have a cumulative frequency diagram. They provide the diagram for us. There's a total of 160 students. So we need to come down here to the questions, find the median. So half of 160 is 80. So we follow 80 across. I would recommend using a straight edge like a ruler. Follow it to the graph, then turn it perpendicular and follow it down. And this is exactly at 5. So 5 should be your answer. And it's 5 hours of time. Then find the interquartile range. So 75% or 3/4 of 160 is 120. Follow it over and down. That gives you 6. And then 25% or 1/4 of 160 is 40. So follow 40 over and down. That gives you 3.5. 6 minus 3.5 is 2.5. They allow you a little window between 2.4 to 2.6. Then they want you to finish the, why do I have the 46th mark there? Where's the 46 come into play? Not sure where that 46 comes into play. Oh, I know where it is. So here, they want you to finish this frequency chart. This is cumulative frequency. So notice at the end of 2, it's already given to be 20. So 2 is connected to 20. 2 hours connects to 20. So now we need to go to 4. So 4 is right here. It connects, go all the way up till you hit the graph and then all the way over, and that's 46. That's why I wrote 46 here. So 46 minus 20 is 26. Remember, this is cumulative frequency. You have to subtract the cumulative frequencies to get just frequency. Then the 6 is right here. You follow the 6 up and you get to your 120. We had already done that one. So 120 minus 46 is 74. And then I think they provide these other ones already, 24, 12, and 4. So we just needed the 26 and 74. Continuing on, here we have linear inequalities. So by shading the unwanted regions, find out the region R that satisfies these 3. So we have y less than or equal to 2. Remember, when you have y equals a constant, that's a horizontal line. So we just go up to 2. Here we put in a horizontal line, solid line because it has the equal to, and it says less than. Less than is what you want. So then greater than is what we don't want. It says shade the unwanted. So we don't want up here. So we shade all of that. Again, they make it bold unwanted because some of the curriculum that we use actually teaches you to shade the wanted part, the solution set. So that's why this is bold, because this goes kind of opposite of what some curriculum teach. So we want to shade the unwanted, the opposite from what the inequality states. So that's why we shade up here in the greater than. Then x less than 3. Remember, x equals a number is vertical. So x less than 3, here's our vertical line at 3. And it says less, so the unwanted would be the more. So we shade this greater than part. Now we look at this y equals mx plus c, crosses the y-axis at 4. So that would be right here, put a dot, has a slope of an understood 1. So you go up 1 over 1, draw your line through those 2 points. And when you read it from the y, it says less than. So that means we don't want the greater than. So I shade all over there. The only thing that's left is this region right in here between the 3, the 2, and this here, those. So this is still unshaded. That is what we want. That is region R, so put a big R in there. Moving down here to this, here we have a pentagon within a pentagon. It says there are 2 regular pentagons. And find angle AEK. AEK. So let's start on the inside. Let's see how much it is for one angle. So a pentagon has 5 sides, 5 minus 2. Remember, it's n minus 2 times 180. That is your formula for the interior angles of a polygon. So since this is a pentagon, we do 5 minus 2, which is 3, times 180 gives you 540. Since there are 5 interior angles, we divide it by 5 to get 108 for each one. Then we see that this line here, if we draw it from the center and connect it to the line that we want here, that cuts the angle in half. So divide it by 2 gives us 54. 54 is this one right here. This makes a straight line, So take 180 minus 54 gives us 126 is what we want there. Now here we have a ratio thing. The area of the bigger pentagon is 73.5. The area of the smaller pentagon is just 6. And we want to find the perimeter, the ratio of the perimeters. Now we're going from area, which is 2-dimensional, down to perimeter, which is 1-dimensional. So we need to square root our ratio of the areas, and that reduces down to 3.5 to 1. We can't have a decimal in there, so we need to move the decimal in the numerator and denominator over 1. That gives us 35 tenths, which reduces to 7 halves. So this is the linear ratio. So that means our perimeter, which is a linear value, will be at some ratio of 7 to 2. And that finishes our paper 23. So hope that helps you. And as always, thank you for joining me, and hope to see you again next time.